Now I am going to explain you the topic tension in string. Tension is the force which is directly exerted by a string on a body with which it is attached. It is denoted by T. Its SI unit is Newton. You will see the example of this string when it is stretched from both sides. So tension force is generated on the string. Two weights are hanging on the frictionless pulley, so weights are acting downward and the tension on the string acting upward. You will see that here is a pulley on which two weights are hanging, that is the weight A and weight B. Okay, weight A is greater than that of the weight B, which is acting downward, and the tension force is acting upward. Weight B is less than that of the tension force. So here uh, the vertical weight of the body acting vertically downward is equals to W1 is equals to M1G, and the tension force which is acting vertically upward is equals to. Now here you will see, since body is moving downward, so W1 is greater than T. W1 is greater than T, which is written over here. After that, force acting vertically downward on a body A. Force acting vertically, the net force acting vertically downward on the body A. Net force कितनी है? W1 minus T, because weight is greater than that of the tension, so we will minus weight from that of the tension. We will write the formula of weight, that is M1G minus T. Okay, now we know that force is denoted by the formula of force is the MA. So we will place the combine both equation 4.5 and 4.4, that is M1A is equal to M1G minus T. Okay, now consider the motion of the body B. Okay, now we will talking about the body B. In the body B, weight is less than that of the tension force. So weight is less than that of the tension force, so we will write F2 is equals to T minus M2G. Okay, in the same way we will apply the Newton's second law, so it will M2A is equals to T minus M2G. Now these are the two equations. Now we will finally combine equation number 4.6 and 4.9. And 4.9, it will be M1A plus M2A is equals to M1G minus T plus T minus M2G. And we will rearrange the equation and we will find the value of A is equals to M1 minus M2 upon M1 plus M2 and G. This is the equation which is derived. This is the case 1 if the if the two bodies of the different weights are the same equation. We will, if we want to find out the T, to calculate T, divide equation 4.6 by 4.9, we get M1A upon M2A is equals to M1G minus T upon T minus M2G. Okay, now then we will rearrange the equation and we will find the value of T. This is the final equation for the tension force. That is in the case 1. We will if we want to find out the tension exerted on the string, we will find out by this. In case 2, M1 is hanging but M2 is on the horizontal surface frictionless on the frictionless pulley. In the second case, you will see that a body is hanging downward, so it have a weight W1 which is greater than that of the tension force. Previous case, F1 is equal to M1 minus T. Instead of W, we will put M1G minus T. Okay, instead of F, we will put M1A. M1 is equal to M1G minus T. Now we will talk about the body B. Three forces are acting on the body B. That is the tension force towards the pulley, the weight which is vertically downward, and the reaction of that horizontal surface. Because the body is not moving, it is on the still position, so the weight and the reaction though both will cancel each other, both will be equalized. So here f2 is equals to t. Okay, so now in the same way we will put the value of f, that is f2a. F2a is equals to t. Now we will combine the two equations, that is 4.12 and 4.15. So we will find out the value of a, and from that value of a we will find out the value of t. Okay, the value of t, put this value of a in equation 4.15, we will get the value of t in this equation. These are the questions which you have to do, define tension and both the cases.